Hey everyone, today I'm going to explain you the one of the best project which I have done, which shows the real software engineering, which I built as a complex distributed microservice architecture system, which involves deep AI integrations with RAGs, Vector, and Azure AI services and cloud services. Let me walk through the project. What is this project is about? This project is almost similar to our Google Notebook LM, where we upload the documents and we can just talk with the documents. Basically, we can learn, get insights, everything, right? That's what we are. So let me create the workspace here. So workspace, I go and create is big data. Let's go and create the workspace here. Once workspace is created, some of the documents. Once the document attached, it's gone basically generate the summary of the document, create embeddings, and store it in a vector database using Azure OpenAI and vector service. So this is how summary has been created. The raw file looks like this is one of the coolest feature we have. Coming back to the workspace. So we can, this is the workspace, we can just start with the workspace, which can is basically provides the response based on all the documents we have. And one of the coolest thing here is not only we are communicating the document, this is the real-time collaborative system which I built. Let me explain what is this means basically. I have already logged in some user here. Let me share this workspace to other user. If I just share it, see, it's a real time notification we get, document also has been shared. So this is a real time system it is. Let's say I say give me the key insights about the document. See, it's a real time. We can see who is asking who. So what it is, everything on real time. If
The
I
key
just
insights from the provider.
let's say I want to go and change the voice to mail, and I just store save it. If I come back to
The key insights from the
see, it's very simple and it's also a very good feature we have in our application. We can also take a quiz directly from here. Let's say if I click on the take quiz, it will open up the quiz for us. So you can just go and take quiz randomly. I'm just submitting. It's a 20% no issues, just the example, and we have the we can also go and create a any quiz like it's on you just need to provide and it's go and create. This is also possible. So and coming to the workspace, this is the real time. It's just very big and real time system and the documents which is being shared. And we have one more feature which is the hardware document. Okay, let's say somebody most recent document. If I just click on it, it go and explains the most recent document. It couldn't find any because this particular guy didn't upload any documents. What if I tell to this user? He already uploaded the big data file, right? Now it should be able to give the response. Let's see. Yes, this gives us based on big data because the guy doesn't have any documents he owns. That's why it will give a response. And that is what technically correct. I wanted to show this. Let me share this to her other guy, which is the QA guy. Let me share it. So you can see the share documents and we can get update whatever real-time updates or the state of the chart on real time for both users, not both users, basically all the users for whom chart is shared. It's basically broadcast the update to everyone. We have the semantic search. Let's say I go and search for something, maybe it doesn't give any result because it doesn't have any files. Let's say I go and search for here what is the data. See, 51% match here based on contacts and files we have. So this was one of the coolest features and quiz we talked about. Coming back to channels, one of the coolest features is channels. So currently I have some channel which is a DAC tool. So you can see also channel for the demo. Let's call that as big data. Also we can provide a tag based on this tag. Basically recommendation will be provided. See go and adds big data. If I come back based on see it's now able to provide me the recommendation. So this is what channel you have. So I just request it. We will also get the real-time join request. So if we go and approve it, it's all get joined, we can post it. Let's say go big data in one shot. Just copy it, come back, go to your page. Big data in one shot. Just try to publish it. And you can see it real time. Any users on the real time. We can also go and upload the files, big data. I can just the data file from here and just publish it. You can see this is so awesome and coolest feature here. And this is the main goal. And user, what if I remove? Immediately it's gone. Access removed. Coolest feature. Coolest feature. So this is all about the demo of my application. You can definitely clone the GitHub, my GitHub repository, and you can deep dive into it. Any quizzes you created but you didn't able to complete, it's able to show it. And our application provides 100 MB file storage by default for every users. And these are the recent queries what we have done as per the AI here. These key insights about how many documents we uploaded, how many AI queries we have done, what is our score on the quiz, and learning recommendations, everything. It's so good here. And I built the application. Is that enough? Not really, right? Because we need to have something for admin control. Who can tell us what are the services currently running? This many services are running, and my gateway is up from 25 minutes. And we have live stream. Okay, what is this live stream? This live stream, once it is connected, whatever we make, we should be able to capture. This is what live stream is. Everything is logged over, and this is the root or request activity ID. Any request activity ID if I give, it gives all the API beware of it. Let's get one of these. Let's say go to this, and I open. Let's say this is what, right? So I just go and see this read. If I go and provide this read, which is for fetching the quiz history, right? This is what two services are being called. And for creating the quiz, four API calls are being created. This is what I actually had already read in my previous history. We should be able to see it. So how we can make use of our admin system to, and this basically uses the SSE clients. This is all about the quick demo of my application how I done. Now I want to go in deep dive of the, so what are the system trade-offs and features basically used and why it used. Coming to the first API or microservice architecture which I used, basically we have two front-end clients who are both are built using the React.js plus White. And if you can see, we have the user front-end and the admin front-end. Admin front-end is what we say for controlling and seeing the logs, how many services are running or healthy or not. And coming to the WebSockets, this is nothing but how our clients will be able to communicate with the backend. We have three ways how our client can communicate with backend. One is the REST API, second one is the WebSocket, third one is the server sent events. Coming to the API gateway, which is a single point of entry to our application, which is secured with Helmet, and each and every event is logged via Morgan, and it's secured with JWT authentication and SQS got via internal key, and we use Redis for distributed rate limitation and sockets, which is basically using the gateway broadcaster. Then we have the microservices. We have 6 microservices in order to work these systems, which are the auth service, document server, AI server, core server, log server, and admin server. Each server here is responsible for their own operations, and these services can only communicate via internal key, which is set from the environment. Then coming to the database layer, we usually using 3 databases. One is the MongoDB, which is the primary database for our services, and the cache Redis, which is basically a cache or in-memory database for storing the rate limiting data, Bloom filter, session cache, etc. And we have Azure AI search or cognitive search for search based on the vector or the meaning. Next, coming to the reverse proxy, So as I said, single point of entry to our server is only the gateway. Means we cannot go and communicate with the other microservices. Basically, whenever you go and ask gateway, gateway will go and forward that request to a specific microservice service, and that will respond and returns the result, and that is how we are able to get back to the client. This is called reverse proxy. Then coming to the service, which is basically a model, which is how our application is able to perform the most of the critical and time-taking actions asynchronously and on real time. Basically, when you upload the document, it's not a quick response like 1 or 2 seconds. It's not like we send request and it will be ready. It will take time. Uploading the document takes time. Creating the embeddings from it takes time. Storing into vector database takes time. Creating a summary of that, passing the documents, everything takes time, right? Maybe it could take 10 seconds. In worst case scenario, it could be 20 seconds. If the file is too large, it could be 2 to 3 minutes also. So if you just use the REST APIs, obviously we get connection timeout and we are not able to serve it. So the best approach is do it asynchronously via PubSub model. So we use as the Azure Service Bus. We can also go with the Kafka, but this is for high-end system. This is basically a very complex system, but it's a kind of not billions, so it's basically for projects. So I didn't choose that, and Kafka is basically very hard to manage in terms of infrastructure and all. That's why we have went with the Azure Service Bus. This is also a PubSub model which also has topics and subscription. We can also create partitions in it. So basically, whenever document uploaded, we push the events to the service on sort of data, and we have the consumers which are nothing but our microservices like AI server. When your document get uploaded, it receives the data from the Azure Service Bus because AI server is one of the subscriber. Now they have a document will be processed and will be stored its state, summary, and everything. This is how we make use of the microservices architecture with PubSub model. Now we have eventual consistency. As I said, uploading document and all, it's a time taking action, right? The task. So basically, in order to reflect the changes to all the services running on parallel, it's not possible because it's a asynchronous updates across these systems. That's why we can introduce bit delay, which is not very critical for our application. If you want the strong consistency, they must make use of the distributed lock on door. This is making system complex and not really necessary for our application. That's why we choose the eventual consistency for our application. Coming to the CDC, which is widely used in our application, because we have to look into our document state update whenever the document state is updated from the uploading to uploaded, processing to done. We have to cascade the updates to the UI. This is where we continuously watch the document using, and this technique is called change data gap. Coming to the server side events, as we saw the admin system, we have something called real-time logs getting, right. This is nothing but done by creating a SSC connection, server side events connection. Basically, it's a live HTTP long connections which sets the header keep alive and sets the header sends the outbit for everything. And whenever some log is done, he has set, which is SSC client, for which response he added. This response client will be using this will be sent. So it's basically a real-time updates, and whenever the connection get closed, it also obviously delete from this set. This is how I implemented the server sent events for my log system. Then we have blue filter. What is this? If you ask me, this is basically for a database, quick database lookup. If user present or not in our database, if the specific document with the help of idempotent key, if it is present or, so it's basically we can go and use the database lookup, but it's going to take a lot of time because if you, let's say you have 1 billion users, is go and search for the 1 billion records, but in blue filter it's only constant. It's a false positive technique. Basically, if the user does not present, it definitely says it does not present. But in some scenarios, it could say probably yes, user may present but may not be present as well. In such scenarios, we'll go and look into the database. But in most of the times, it's a constant time complexity and it is the efficient approach. And coming to the Redis, which is the in-memory database, which is widely used in our application for distributed management of the rate limiting or socket scalings, caching. Also, blue filter, which is the huge array stored in the distributed Redis system. Then we have the circuit breakers, which is basically prevents the cascading failures. For example, let's say the AI service which I built. which is failing because of API limits. So it need to have some break in between before it start making the request, right? For this, we have to make use of circuit breaker. So if the error is occurring continuously, it will just open up the circuit breaker and does not follow any request to move forward, so that we safeguard our system become much more resilient. Coming to the idempotency, which basically making sure that operation is done once and prevents the duplicate processing, and then shows safe retries of the application, which we are very importantly using for document processing and all. Vectors, so whatever, whenever the document get uploaded, we pass that document content, and this text will be mapped into numerical form using the embedding vectors. And whenever we search it, it's searched by the meaning, not by the text, by the way. This is whatever one of the application feature. Then we have the RAG, which is retrieval augmented generation. What we do, whenever the prompt is given, it fetches the specific documents required and retrieves the document and given to the LLM, which basically gives the context to the LLM, so that it reduces the hallucination by grounding responses, because we have embedding documents, it has full context, so it provides a better results for us. Gateway broadcasters, since we are in the microservice architecture, whenever some service wants to send some real-time data to the client, it cannot directly send it because there is no connection between client and microservice. So it cascade it into a broad gateway. Gateway will usually broadcast into the clients. So that is what it's saying, that it's a centralized real-time event delay. So then we have observative using RAID, which I show you how we are each request gets the RAID, and using that RAID we should be able to trace the request from end to end, how it is being done, logs and everything. It is very easier for debugging and monitoring. And S2S God, so as I said, only the API gateway or internal no microservices can communicate each other. No one from outside our application can really communicate. That is what S2S God using the internal key. So yeah, that's all about my application. So I would request you to go to the GitHub and clone it and try it out yourself how it works. So this is basically a good application which I built, and deep integrated application, which is our resumes in 2026.